Welcome to Bald Guy DIY. In this video, I'm going to explain how using long extension cords to power your devices can cause some problems and some of the things that you need to do in order to avoid them. Over the years in my career as an electrician, I've run across a few different circumstances where someone was using a long extension cord and getting strange results or premature failure of their devices because of it. Now, when you think about using an extension cord, often we don't think about it being any kind of problem because on one end, it plugs into our outlet, and on the other end, it fits perfectly the device. And as long as there aren't any weird complications that we can observe, we think that everything exists completely as normal. If you watched my video on wire sizes and ampacity, you'll realize that there are some effects that are created every time we use a wire to conduct electricity. Whenever we use a long run of wire, we're introducing a few variables into the circuit which can cause it to have a negative effect. Of course, the resistance of the wire itself reduces the voltage that's available to power the device because that wire resistance is in series with the load. There's also a capacitive effect with the insulation on the wire, which can cause it to have a greater and greater influence on the voltage the longer the span of wire. The resistance of the wire and the capacitive effect of the insulation mean that at the end of a long stretch of an extension cord, you're going to have a lower output voltage than the voltage you started with at the beginning of the extension cord. This is called voltage drop, and it's an important factor in how we power our devices. Now, most of the time in a residential or commercial application, we're going to be using single-phase extension cords, which are going to take 120 volts and supply that to something far down the line, like a fan or a tool or something like that, that we need that's a long way from the outlet. The total voltage drop that you experience with a long extension cord ends up being pretty significant depending on the type of load that you're going to put on it. Electronic devices like computers, cell phones, laptops, anything like that typically won't be affected by these long extension cords because they take the incoming AC power and transform and rectify it into a DC voltage that will supply the device. Devices such as a computer that typically has 120 or 240 volts AC supplied to it are going to transform and rectify that voltage so that they're providing 12, 5, and 3.3 volts to the various electronic components in the computer. Cell phones, that kind of thing, are typically run off USB, and those USB devices are 5 volts DC, which are already going to be transformed and rectified down to a steady 5 volts. The devices that are greatly affected by long extension cords and the voltage drop that comes from them are heater loads and motor loads. Now, heater loads are affected simply because they're going to output less power. The power formula is a combination of the voltage times the current draw of the device. And if you lower the voltage and have the same resistance, you're going to have a lower current flow and you're going to have less power as a result. That less power means that less heat's going to be created and that device is going to run cooler than it would with a higher voltage supply. So for example, if you were going to supply a portable heater with 120 volts, or if you were going to supply it with only 100 volts, you're going to see a voltage drop off of about 1/6, and you're going to see a power reduction of about 1/6 as well. Anything that generates heat as a main point of its functionality is going to be affected by having this voltage drop because of a long extension cord. There isn't really a lot that you can do to change this from happening when it comes to the device itself, except if you consider that where you might have used a lower heat setting before, you're going to use a higher heat setting if it's available on the device. Electric motors come with a nameplate that describes the voltage that they're supposed to see, as well as the current that would be expected at that voltage when the motor is operating at full load. When it comes to motor loads, there's some extra factors involved, and the effect that's created is different. The main reason for this is that a motor is not going to reduce its speed because of a lower voltage. The speed of an AC electric motor is actually determined by the frequency of the supply, not the amount of voltage. In North America, that frequency is 60 hertz, which means that 60 times per second, the alternating current is cycling. And that means that a standard 2-pole motor is going to run at around 3,600 RPM, a 4-pole at around 1,800 RPM, etc. The reason this becomes a problem with electric motors is because they're basically created to work under the same set of circumstances, and when you adjust the amount of voltage that's being supplied because of the voltage drop, it causes the motor to operate differently. In an electric motor, unlike a heater, as you reduce the voltage, by keeping the torque requirements the same, instead of reducing the current and reducing the power output, the motor is instead going to have to work harder to produce the same amount of torque to power the same device, in which means that it's going to raise the current. So lowering the voltage because of a voltage drop on a heater is going to reduce the output, and it's going to make the device run with less current. But in an electric motor, it's going to be the opposite. By reducing the voltage supplied to an electric motor, it's going to increase the amount of current required to produce the same output, and it's also going to have a couple of unintended consequences. The first problem is that the overcurrent devices, that's the breakers or fuses that are powering that circuit, are going to be strained and possibly cause them to trip, even though the device itself is only rated to draw an amperage that's within the tolerance of that device. If it draws a higher current because of the lower voltage supplied, there's a potential to trip those overcurrent devices. A second problem is that more current creates extra heat than what the device was originally rated for. So when it comes to something like a vacuum cleaner or leaf blower or something else with a long extension cord, it's possible that that extra heat is going to deteriorate the insulation faster. And in extreme cases, when you're out there using it for hours on end, it may even cause the wiring insulation to melt or other parts of the components to melt, because a lot of them are typically plastic, and cause the device to fail completely. Because motor loads operate kind of opposite to the way heater loads are, it might seem strange that they actually trip or overheat, because a heater will actually underheat. But that's the way the electricity works, and if you understand magnetic flux and the way it's created, it'll make a lot more sense. Basically, if you have a motor load on a long distance, especially if that motor is powering a fan, airflow, water flow, anything like that, its performance is going to be affected, and cooling that device properly and also not overloading it are really important. If you overload it even slightly, or even run it close to its load, it might actually fail because of extra heat. One final problem with electric motors is as you increase the current and you increase the magnetic flux in the core of the motor, you may actually reach a point of saturation. If that happens, instead of the temperature rising 10 or 15 or 20%, it might drastically increase, both spiking the amount of current required and also spiking the temperature very quickly. So what do you do if you need to power one of these devices, but it's far away from an electrical supply? Well, there's a couple of options. The first one of those, and sometimes the simplest, is just to get an extension cord with a larger gauge. Now, depending how long that length of cable needs to be, it could be a lot more expensive than the extension cord you were already using. But by increasing the wire gauge, you're actually going to reduce the voltage drop, which means that it'll eliminate or reduce the effects that are caused by the voltage drop. The other option you would have is to find a portable power supply. Something like a portable generator, maybe gas, diesel, or propane powered, which would be able to take up the supply and provide a proper amount of voltage right near where you need to use the device. Or instead of using an electric device, like a fan or a pump, you might be able to substitute it with a combustion engine device instead, as they do make gas-powered fans and also pumps that are available for different emergency type situations or portable pumping circumstances. When it comes to voltage drop, this effect is not really something that you can completely eliminate, but if you understand how it works and how you can reduce the effects by either a larger gauge wire or by using a portable power supply, you'll find your devices will last longer and you'll have a lot more of the unexpected consequences as you go forward. I hope that little bit of information can help you, and if you're experiencing weird quirks or breakers tripping unexpectedly, devices failing, these are the kinds of things you need to be aware of in order to make different choices. If you find these videos helpful, please let me know in the comments, give the video a like, subscribe to the channel, and check back weekly as I post a new video every weekend. Follow me on Twitter or send me an email. My information's in the description below. And until next time, in all your electrical dealings, projects, whatever else you have going on, Don't be afraid to be balder.